Okay. So, in the last class, we started with complex random variables, right? So, now today I take two complex random variables, x, which is a real part x r, which is a real continuous random variable, plus j x I for imaginary, x r and x I, two real continuous random variables, and they are combined like this. So, capital X is a complex number, it is a complex random variable, and there is one more, y r plus j y I. So, two complex numbers means two complex random variables, x y mean actually four real random variables, right. So, also given E of x r, whether you put x r comma x I here or just x r does not matter, because x I does not figure here, so that will drop off. So, it will be E x r of x r, which is mu r, not mu r, let me change the notation to something else, mu of this random variable. So, mu x r plus j, sorry, not plus, I am very sorry. I am wondering whether this is a good notation or there can be something better. Okay, let it be as it is. Similarly, x I has this mean mu x I, E of y r is mu y r, E of y I is mu y I. Then consider a function of x and y, or equivalently a function of x r, x I, y r, y I. This function, it is a function of x y, and x has two components, y has two components. So, it is basically a function of four components, and it is this E. Either you write x r, x I, y r, y I, and then x minus, so mu x is expected value of this, and x you write as x r plus j x I. So, E x equivalently now have got two variables x r, x I. When this works on x r, x I drops off. So, it is E x r of x r, which is mu x r, plus j. When E x r x I works on x I, x r drops off. So, E x I of x I, which is mu x I. So, j mu x I. Similarly, mu y will be mu y r plus j mu y I. All right. So, here I write like this x y, x minus mu x, complex, and sorry, it is not, y minus mu y, but I put a star here, conjugate. Okay, I am just constructing a function x minus mu x, y minus mu y star. Okay. What does it mean? That x is a complex random variable, its mean is mu x. So, x minus mu x is the increment over the mean, y minus mu y is the increment, complex increment over its mean and star, and you are multiplying them and then taking average. So, suppose x and y, they are highly correlated. So, when x minus mu x and y minus mu y you multiply, okay, when so you will get a good product. Okay, product, if you take the magnitude of actually, actually magnitude wise, and if you average them, it will be high. On the other hand, if you, I mean, because what happened is it has got, maybe you will understand it better if I expand it, right, like So, x you replace by xr plus jxir like that. So, it is xr minus mu xr from here plus j xi this is x minus mu x and yr. If you multiply them and there is a star here, sorry. So, if xr and xi they are highly correlated to yr and yi, then when this is positive and this is positive, this also will be positive. It is going up over the mean, it is also going up over the mean, same here, suppose. So, products will give high positive value and you will have a quantity of high magnitude. Or if they are going down the mean, when this also goes down, this also goes down. So, negative, negative, again negative, negative. When you multiply, you still get a positive number. So, you get, and then you average your overall magnitude of the average will be high. But if they are not correlated, then sometimes this is positive, half of the cases this could be negative, this could be negative, and another half cases this could be positive, this could be positive, same here. So, when you multiply and average out, you will be getting close to 0. So, it is a more general definition of covariance, it is a complex covariance. Okay, between x and y, it is a complex covariance. Alright, when x and y are same, why we need the star? Because when x and y are same, then it is x minus mu x. If I put star, then only we will have mod square, because if it is covariance and when x you are taking covariance of x with itself, then it is variance, and variance cannot be complex, it is the power, average power. So, unless you put star there, you won't get real thing here. If you put star, it will be x minus mu x, and this is now x, so x minus mu x again star. So, a complex number into its star. So, it is mod of the complex number square, which is real, and so expected value is real. That is why the star has come. Alright, this complex covariance. And as before, if x and y are uncorrelated, this covariance will be 0. Okay, this covariance will be 0 if this is uncorrelated. In that case, if you expand it without breaking like this, it will be EXY xy star minus mu x is a constant, it will go out of expectation. So, E xy y star. So, since x does not figure inside, x will drop off, and then minus mu y star EXY of x, and again y does not figure here, so y will drop off, plus mu x mu y star expected value. So, that will come out is a double joint density. You have to multiply this by the joint density and double integrate. So, this will come out of the integral, and joint density double integral from minus infinity to infinity equal to 1. So, it will be minus minus plus mu x mu y star. But this is equal to, this is the what is this? Other day I told you, if E y is mu y. So, E y, like I told if you are doing E z of a function f of z, fine. But if you do E z of a function f star z, then it is nothing but star of E z of f z. So, f z you can take to be z. So, E z of z star, it is star of E z. Okay. So, it will be star of E y of y. That means E y of y is mu y. So, it will be mu y star. And this is simple mu x. So, mu x mu y star, mu x mu y star, mu x mu y star. So, 2 cancels, so you are left with this quantity. Minus just mu x. Okay. This is called the complex correlation. Or x y minus this. So, it is a more general result. There is a extension to the complex case, extension of the earlier previously discussed covariance and correlation case and all that, uncorrelatedness, all those things to the complex case. All right. One more thing. Now, suppose we are given P complex random variables x1, which is x1 real part plus j x1 imaginary part dot 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 xp, which is real part imaginary part, expected value E, expected value will be mu x1, here mu xp, expected value on this, fine. So, as before, I form this increment vector x1 minus mu x1 dot 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 xp minus mu xp. Okay, let me give it a name x. Any column vector will be an underscore lowercase letter. Any matrix will be an underscore uppercase letter. And if it is not underscore, it will be scalar, whether doesn't matter if it is lowercase or uppercase. But underscore means either vector when it is lowercase or matrix when this is uppercase. So, suppose this is this and I call it x tilde. Then x tilde okay. Before this I need to do something called Hermitian operation. Fine. I will come back to this. And if I cannot come back today, next class. Given there is a separate thing I am now considering, Hermitian transpose of a matrix or a vector. In fact, a vector is also a matrix. N cross 1 column vector is actually n cross 1 matrix. So, no need to write a vector, okay, because there is any vector also is a matrix, whether row vector or column vector. Okay. This first we discuss Hermitian transpose, then I will go to the previous page. There I discussed a matrix x tilde, I will take its Hermitian transpose, then I can proceed. That is why I am doing this here. So, given a general complex valued matrix A m cross n, its Hermitian transpose, you know ordinary transpose, it is indicated by a superscript T. Here it will be a matrix, that is uppercase and underscore, A, not T here, but capital H, it is called Hermitian operation. H will be either you conjugate, take complex conjugate of each entry, then on that matrix apply ordinary transposition, or alternatively you can first transpose and then conjugate, you will get the same thing. First you conjugate everybody, then transpose, or you first transpose and then conjugate everybody. This obviously they will be same. So, this is equivalent. So, if it is m cross n, after this it will, if it is m cross n, this will be n cross m because transposition. Alright. Now, one thing we know, now suppose we are given two matrices A, which is say maybe m cross n, and B, which is maybe n cross r. So, if I do A, B, m cross n, n cross r, so resulting is m cross r, m cross r. There is a matrix. If on that matrix I apply H, so m cross r matrix, after this H it will be r cross m, fine, r cross m, but what it will be? We have to say this. Now, if you call it this matrix to be C, which is m cross r, m cross n, n cross r, m cross r, CH will be, you first take C star, one of the two, I take this for C star and then transpose. C star means everybody in the C matrix. What is the C matrix? Typically, ith row of A and jth column of B, when you multiply them, you get I comma jth element of C. Okay. Then you have to start, this is A, this is B, and then you have to, 1 minute. And then outer is transpose. A, B, C, C star. Now, every element of C is to be conjugated. So, ith row of A and jth column of B, when you multiply them term by term and add, you get Cij, right. So, Cij is what? AI1, B1j plus AI2, B2j, and like that. So, it is AI, you can bring an index k, and BKJ, k from 1 to, k will go like this. How many? N columns, k is 1 to n. AI1, B1j, AI1, B1j, I1, B1j, then AI2, B2j, then AI3, B3j, like that you add. Okay, up to n times, n times. So, if I want to star, you have to conjugate every element of C. So, I comma jth element of C also is to be conjugated. So, if I want to conjugate it, you have to conjugate this. But you know, conjugate of a summation. If I give you two complex numbers Z1 plus Z2, if you sum and then conjugate, it is same as this. You can verify. First you conjugate and then sum, and you can extend it to any number of complex variables. So, star over a summation is summation over star of these. One minute. And one more thing, maybe here only I can say, if you have given two complex numbers Z1, Z2 product and you want to star, you can verify that it will be Z1 star, Z2 star. Very simple. Z1 you write in the polar form, some R1 times e to the power j theta 1. This you write as R2 times e to the power j theta 2. So product is R1 R2 into e to the power j theta 1 plus theta 2. Conjugate means it will be minus j theta 1 plus theta 2. So R1 e to the power minus j theta 1, R2 e to the power minus j theta 2. Z1 star, Z2 star. So when you apply star, star of a summation is summation of conjugated. When you apply star over this for every k, it's a product of two complex numbers. Star over that is product, I mean you have to star each one like Z1 star, Z2 star, so you have to put a star here, put a star here. So first you conjugate, then multiply, alright. That means as though ai star k, as though this element, so k equal to 1, say ai star 1. So this one is like if you do a star, b star, then what will happen? It will not be ai1, it will be ai1 star, and it will not be b1j, it will be b1j star, and that is what I have, I1 star, b1 star. Then I2, if you have a star, I2 also, every element is conjugated, so I2 star and b2j star, and that is what I have here, I2 star k is to b2j star, and like that. So it means every element of A is to be conjugated and every element of B is to be conjugated and multiply. It's a matrix, it's a matrix. So A star, B star, then transpose. So it's basically A star, B star, then transpose. But this is a matrix, this is a matrix. You know from basic matrix results, if you multiply two matrices and they transpose, it is first you have to transpose this second fellow, then you have to transpose this first fellow. These are very basics. You have studied two matrices A, B multiplied, then transpose, A, B transpose is B transpose, A transpose. Here instead of A, B, it is A star, B star. So, B star transpose, A star transpose. But B star transpose is, by this definition, B star transpose is BH and A star transpose is AH. So, this gives us the result. AB you multiply, then take H, that is conjugate everybody and then transpose. That matrix will be same as if you first apply H transpose on B, that is conjugate everybody of B and then transpose, and again conjugate everybody of A and transpose, or vice versa, then multiply, you will get the same thing. Alright. That is this main result ABH is BH AH. So now I go to the previous page. I take this increment vector, which is a column vector n cross 1, and I take its Hermitian. So if it is n cross 1, this will be 1 cross n. So column vector, row vector, and everybody after transposition, everybody will have to be conjugated. That is, and then I take expected value. I am not writing in the superscript anymore, it is with respect to all the real and imaginary. So, 2p variables here, this has 2, everybody has 2, real, imaginary, real. So, total 2p number of random variables, real random variables, they come here. That is invisible, I am not writing anymore, okay, now you should be able to understand. So, this is E of these in general xi minus mu xi and then Hermitian means transpose and conjugate. If you transpose it, you get a row vector and then conjugate. So, this every element will be conjugated. Take a jth guy, take a jth fellow xj minus mu xj star dot last guy xp minus mu xp star and then expectation, right. So, column vector into row vector will be matrix. In that matrix, I comma jth element will be what? Ith guy from here and jth guy from here. They will multiply expectation. So, this matrix, if I call it C, actually it will be a complex covariance matrix C, CXX, complex covariance matrix. So, CXX, its typical I comma jth element will be what? This fellow times this fellow, ith guy. How the matrix is formed? This into this expected value, first 1 comma 1, then this into next 1 comma 2, this into next, like that. So, ith row, ith fellow here and jth fellow here. When you multiply, you get the I comma jth element of CXX. And what is that? That is E. I am not writing anything in the subscript, it is up to you, you understand now. It will be only the two random variables like real part of xi, imaginary part of xi, real part of xj, imaginary part of xj, just 4 of them present, others drop off. And I have got xi minus mu xi, xj minus mu xj transpose, which is covariance by your definition between these two random variables. That is C may be xi. This is not matrix, this is scalar, C x I x j. So, that is why it is called complex covariance matrix. Okay. We will study properties of this matrix later in the next class. Okay. Till then, goodbye from here.